Audio Jungle. Audio Jungle.
Hello everyone, myself Narendra Singh Maurya and hope you all are doing well. Today we'll solve jet propulsion problem GATE 2022. So this is problem number 34, right? So here first we'll read the problem and we'll write the given data. So in a static test, turbofan engine with a bypass ratio of 9 has core hot exhaust speed 1.5 times that of fan exhaust speed. Okay. The engine is operated at a fuel to air ratio of F is equal to 0.03. Both the fan and core streams have no pressure thrust. All right. The ratio of fan thrust to thrust from the core engine is. So this is the fill in the blank problem. We have to calculate the data and we have to fill here. Okay. Now, so we'll write given data, guys. Okay. So this is what given data. So that bypass ratio they have given. So basically, bypass ratio, it is denoted by beta, and it is nothing but mass of the cold air, mass flow rate of the cold air divided by mass flow rate of the hot air. This is what bypass ratio. All right, I'll show you the turbofan engine diagram, so it will be very clear to you. This is the first value, and second, what they have given the hot exhaust speed, core hot exhaust speed. So we can say like exhaust speed is what VE, and it is core hot. So we'll write hot exhaust speed is 1.5 times that of fan exhaust speed. So remember, fan is what? Cold air. Okay, cold. So basically, it is VE for the cold air exhaust speed. For the fan, it is given by VE cold. All right, this is the second data. Third, they have given fuel to air ratio. So fuel to air ratio, it is denoted by small f, and it is nothing but fuel to air ratio. So means mass flow rate of the fuel divided by mass flow rate of the air. So obviously that fuel is what injected in combustion chamber where hot air you may get. So this is m dot f, and instead of m dot a I will write m dot hot, because in combustion chamber we'll have a hot air. All right, this value, it is given how much? 0.03. Okay, now what we need to calculate, check. They are saying we need to calculate the ratio of fan thrust. What is the fan? I told you it is the cold air. Okay, so fan thrust, will write T fan, you can write, or thrust for the cold air you can write, no problem, divide by thrust from the core engine. Core means there you may have a hot air, right? So you can write directly T hot, means thrust due to hot air and thrust due to cold air. That ratio you need to calculate. Okay, so T fan also you can write cold. Cold thrust divided by hot thrust. That's the mean of it. This value you need to calculate. One very important remark point I will tell you here. What is the remark? They have given a static test. Okay. What do you mean by static test? Test means it's very clear. Like engine is what working. Okay, that's the reason we have a exhaust speeds they have given for the hot air and for the cold air. Okay, bypass ratio they have given, but in static test that airplane speed will be 0. That's the mean of it. Okay, airplane speed, which is nothing but VA, that will be 0. That's the mean of it. Okay, this is the remark point. That's the reason they have given in static test. So that should be very clear. All right, I will show the turbofan engine here so that hot air and cold air will be clear. Check. This is the turbofan engine. All right, this is what? Turbofan engine. All right, this is basically, this is the total air. Okay, check this total air, basically divided in two parts. One is fan, another is what? core. Fan means that cold air. I told you, cold air. So check, this is what basically fan. If you check this part here, this part, this is what? Fan. See, this is what? Fan. Yes or no? So this total air is nothing but M total, and this M total is what divided in two parts. One will be M dot fan and another will be M dot core. Core means core, it related to the gas generator. What is the gas generator? Where compressor is there, where combustion chamber is there, where turbine is there. So that combination, gas generator is the combination basically. Okay, gas generator. So this is the combination of compressor part, then combustion chamber, AC I will write, and then turbine. So this part all together called a gas generator. All right. So whatever the air passing through the gas generator will be called as a core. Okay. M dot core, and whatever the air passing through the channel where we don't have fuel injection and all, okay, that is called a cold air or fan air. And obviously these two streams will be divided by the fan. So this fan will divide this total air in two parts. One part will pass through the core of the engine where compressor is there, combustion chamber and turbine is there. So that air will be called as a M dot core, which is also hot air. You can say M dot hot. It should be very clear. I will write here M dot fan. You can say this is M dot cold air. M dot means mass flow rate. Similarly, M dot core, you can write it is M dot hot. Hope you understood. Okay. So this is the one nozzle which is called a cold nozzle, or you can say fan nozzle. Similarly here also, okay. And this is called a core nozzle, which is also called as a hot nozzle. Check this red streams here, it is showing means this is hot air, okay. And obviously if you check in this diagram, the diagram should be very clear. So obviously this is the blue, yeah? Blue air here it is coming. Blue air means cold air, okay. This is what cold air. Cold air is what coming like this, okay. It is like this only, and here it will be mixed. Yes or no? So here it will be mixed. So this is what hot and this is what cold. Hope you understood. So what is the bypass ratio? I told you bypass ratio is nothing but beta, and it is the mass flow rate of the cold air divided by mass flow rate of the hot air. Yes or no? So we are talking about the engine only because that airplane is what static condition, because this is the test only. Here it is clearly mentioned in the problem in a static test. Check, in a static test it is clearly mentioned. Okay, so aircraft will be in static condition. Actually it's the engine operation only. We are talking about the engine, that velocity and all. All right. And fuel air ratio also given. What is the fuel air ratio? F. I told you mass of the fuel injected divided by mass of the air. So where fuel will be injected? In combustion chamber. See, this is the combustion chamber. CC, this is the combustion chamber. So we are injecting fuel here. No? We are injecting fuel. So fuel we are injecting M dot F. All right, M dot F is the fuel injection. Both sides. Here we are injecting fuel, no? In combustion chamber. Yes or no? So combustion chamber, that fuel will be injecting, and what will be the air? Air will be hot air. So better this fuel air ratio can write M dot F, mass of the fuel divided by mass of the air, and mass flow rate of the air is nothing but hot air, because that fuel is what injecting in combustion chamber, and in combustion chamber we have a hot air. So this is the brief description about the turbofan engine. All right, now we'll solve this problem. Okay, whatever the data they have given, based on that we have to solve. All right, now check. One more thing they have clearly mentioned: no pressure thrust, because total thrust is the momentum thrust, plus pressure thrust. So they have clearly mentioned no pressure thrust. So we'll make pressure thrust 0. We'll talk about only momentum thrust, mass into velocity. Simple. And in that also, because in mass momentum thrust also, we have to consider both. That because of the motion of the aircraft also will get the thrust, but we don't have any speed of the aircraft, so that part also will be 0. So we'll get only momentum thrust will be mass flow rate into exhaust velocity. That's all. All right. Anyway, so here I will write the equations. You will understand. Don't worry. So this is the brief description, and the diagram here I have explained in very short time of period. Now we'll solve the problems here. Okay. So as per given data, we'll write the thrust for, first. So total thrust is momentum thrust plus pressure thrust. That you know, but here this value is 0. Already they have mentioned. So what is the thrust? Total thrust. Total thrust here T I will write, and I will write this thrust first for the fan. Okay? Or this thrust for the total thrust, here I will write T. Okay. So this fan thrust will be also cold thrust. Cold thrust means mass flow rate of the cold air into exhaust velocity of the cold air. Similarly, you can write this is nothing but m dot fan of exhaust fan. Is that clear? So here in the diagram I have explained this will be the cold air, and whatever the mass flow rate in the cold nozzle will have a m dot fan. Okay, and here this inside this we have m dot core. All right, now we'll connect this. So this is the one formula. Another you have to write for the core thrust also. Core. So this core also called thrust due to hot air. So here you can write mass flow rate due to hot mass flow rate into exhaust velocity of the hot air. Similarly, here also you can write the same thing, m dot core into exhaust velocity of the core, so that it should be very clear. All right. What ratio they are asking? Check. They are asking the ratio of fan thrust to core thrust. No? So we'll write T fan divided by T core. Check. What is the T fan? I will write m dot cold into exhaust velocity of the cold air divided by m dot hot into exhaust velocity due to air. All right. Okay. But here just I want to clear you. Okay. Check. I mean, in terms of mass flow rate, I have written it's okay, but they have given the fuel air ratio. So fuel air ratio they have given. So just simple concept you apply. If fuel ratio is not given, then whatever the equation you have written, it will be correct. But can you tell me in core thrust, we are getting only mass flow rate of the hot air? No, we are not getting only mass flow rate of the hot air. Here in core thrust, mass flow rate of the fuel will be added. Yes or no? Why it is? Because the fuel air ratio they have given. If they have not given, then directly you can write m dot hot, no problem. M dot hot you can write, because mass flow rate of the hot air into velocity in this hot nozzle will give the thrust in core. Okay, but here in the problem they have given fuel air ratio also. It is clearly mentioned fuel air ratio means fuel will be added. If fuel will be added in this core, so obviously that fuel mass flow rate and mass flow rate of the hot air will be added, and if you check the exit here, so in this exit two parts will be there. What will be the parts? One will be m dot f, that is fuel, and another will be m dot hot. So this total mass flow rate will be you have to write here, will be, I mean it will be added here. So that's the reason m dot hot plus I can write here. So let me correct this. Okay, generally this is the formula, but fuel air ratio will be given, then you have to add. If they have not given, then no need to add here. So here it is given, so clearly I will write this part better, no, here only. So once again I will write this. Okay, all right, check. So hot will be hot thrust will be m dot fuel plus m dot hot air into V exhaust of the hot air. Now it is clear. Okay, or you can write m dot fuel plus hot air, also called m dot core, okay, into V exit core. I think it is clear now. Here it will be m dot f plus m dot, okay, hot air, no, into V exit hot. All right. So the same formula you can take the common, and what will be the common here? You can write m dot cold as it is into V cold, okay, divide by m dot hot. We can take common, and why we are taking common I will tell you. Check what is the m dot f divided by m dot hot air. It is nothing but mf by m dot air, no? What is the mf by m dot air? That is the fuel ratio, small f, and that value they have given. How much it is given? I think 0.03, no? 0.03, yes or no? 0.03 they have given. Okay, so I will write here thrust due to fan divided by thrust due to core. Okay, check. So m dot cold by m dot hot will write one side. So in numerator only I can write m dot cold divided by m dot hot. Okay, into V exit fan or cold. Okay, you can write anything because I already explained many times, like cold and fan both meaning same. And in bracket what we have uh, 1 plus f. F is the fuel air ratio into V exit at check. Now it is clear. See, this m dot cold, m dot hot I have taken in numerator. In denominator m dot by m dot h we have m dot f by m dot h is nothing but a small f. So 1 plus f into V hot. You can check this. Okay, it's simple only. We'll write all the value. Now can you tell me what is the V hot V cold? Sorry, this is the V cold divided by V hot. This can also be written as V cold. Cold means fan divided by hot means core. Can you tell me what is the ratio here it is given? Check. See, V hot is equal to 1.5 times V cold. So you can say V cold by V hot is nothing but 1 upon 1.5. Yes or no? V exit cold of the cold air divided by V exit of the hot air will be 1 upon 1.5. So this should be very clear. So this ratio they have given clearly 1.5. Now all the value we need to write here. It is T fan divided by T core. I will write this m dot cooled by m dot hot, which is nothing but bypass ratio. See, m dot cooled by m dot hot. What is that given? Value m dot cooled by m dot hot. Check m dot cooled by m dot hot. How much it is given? See, 9. So this value is 9. Okay, all the value you need to write here. So check. It is nothing but 9. Okay, and divided by 1 plus small f is how much? 0.03. Okay, what is the V cooled by V hot? It is 1 upon 1.5. We'll calculate this value. Wait, let me check. So 1 plus 0.03, okay, into 1.5, and it is 9 divided by this value. So here we are getting 5.85. So I'm getting 5.85. This is the ratio. Okay, it is 9 divided by 1.03 divided by 1. It is 1.85 or 1.82, something you are getting. All right. So here that ratio they had asked. Check. So this ratio you can fill here. What is the value you are getting? 5 point, you can say 5.85 or 5.82 approximate. One decimal they are saying, so you can write 5.8 something. I hope you all understand this problem. It was very simple. Okay. So brief description of the turbofan here I have given with this sketch diagram. But yes, once I will start the subjects, and that time I will completely will go through all the details of the engines related to turbojet, turbofan, turboprop, ramjet, and all. Okay. Here it was only a brief description related to problem. It is given here. Okay. All right. Now we'll go for next problem. So hope you understood. This is the answer. All right. Now check. This is the next problem. This is the problem. Okay. And in this problem, check. This is what ideal ramjet. Problem number 64. This is the ideal ramjet. An ideal ramjet is to operate with exhaust gases optimally expanded. So few terminology, technical words they have given, so that meaning you should understand. Okay, like optimally expanded. So optimally expanded or fully expanded meaning is same, and it is clearly mentioned optimally expanded to ambient pressure. So means what is the mean of this? Its meaning is very clear. Whatever the pressure at exit, that will be equal to ambient pressure or atmospheric pressure at that altitude. That's the mean of it. Exit pressure will be equal to ambient pressure. That's the meaning of the optimally expanded nozzle or optimally expanded exhaust gas. That's the mean of it. Anyway, so this is problem number 64 we'll solve. So first we'll write the given data here. Okay, given data. Uh, See, ideal ramjet, first of all, this remark point, you remember what is the ideal, I will tell you. So this is not only ramjet, this is the ideal ramjet. Ideal ramjet means, remark point you need to remember, no losses. Means no shock formation. Why I'm talking about the shock formation and all here? Because ramjet, this engine will always fly with supersonic speed. Okay, with supersonic speed. And supersonic speed means m greater than 1. M greater than 1 means shock formation will be there. But here it is clearly mentioned, ideal ramjet means will not talk about the shock formation. There is no shock formation. It is still flying with supersonic speed, but shock formation will not be considered in our calculation. So that's the reason it is clearly mentioned an ideal ramjet. That should be very clear. All right. Optimally expanded, I will write this. Okay. optimally expanded. That means fully expanded. That means exit pressure is equal to ambient pressure or atmosphere. That's the mean of it. Okay. It is flying at any altitudes, and at that altitude, that temperature here it is given. Okay. So at that altitude, temperature, an ideal ramjet to operate with exhaust gases optimally expanded to ambient pressure at an altitude where temperature is 220 Kelvin. The exhaust speed at the nozzle exit is, okay. So temperature I will write 220 for the air. I will say because it is the ambient temperature, so I will write T infinity, and it is nothing but 220 Kelvin. All right. And exhaust speed at the nozzle exit. So V is given. Okay, how much? 1200 meter per second at temperature of. So exit at temperature. So it means that exhaust velocity or exit velocity they have given 1200 meter per second at 1100 Kelvin temperature. It means it is the exit temperature. T exit. Remember, okay? T exit. I will write full. T exit. How much? 1100 Kelvin. All right. And this is the another given data like gamma 1.4 at 220 Kelvin temperature, and R characteristic gas constant for the air. So this is for the air they have given, and because at exhaust definitely it will be gases, because fuel will be added in combustion chamber, so it will be a gases. So for the gases, gamma will be 1.33. Temperature at the exit obviously it is 1100 Kelvin, and here also they have mentioned R value will be changed, but they are considering R value will be same. So okay, we'll take R value to 87. All right. Now they are asking cruise speed of this ramjet engine. So what is the cruise speed? Cruise speed means speed of the aircraft. Cruise speed means speed of the aircraft we need to calculate. All right. So that's all. Now, for the ideal ramjet, what are the assumptions for the total pressure, for the total temperature? So here the same like turbofan. For the previous problem, I had given a brief description, brief information related to the engine. Now here we are talking about ideal ramjet. So related to ideal ramjet, I will give the brief description. Okay, so please just see, concentrate on here. Now see, so this is the ramjet. Okay, this is what ramjet, and check it is that the station is given like this is the station A 1 2 3 4 5 6, and obviously 6 will be the exit point. All right. So it is the optimally expanded. So definitely at the exit, whatever the pressure will have, this pressure will be atmospheric pressure, which is called ambient pressure. All right. Anyway, check this is the nozzle part. Obviously, this is the convergent nozzle. This is the throats. You can say this is what throat. No? This is the throat. This is the convergent part, and this is what divergent part. So basically, this is what CD nozzle. What type of nozzle we have here? It is called CD nozzle. Why we are using CD nozzle? Because ramjet is what flying with supersonic speed. Okay, so definitely whatever the flow we are getting here, this flow. Okay, wait. Whatever the flow we are getting, that is the supersonic flow. Huh? So whatever the flow we are getting here, this is the supersonic flow, which means m greater than 1. So A means atmospheric air, intake is what atmospheric air. Obviously, this is the supersonic compression here. This is the spike. The spike shape we have. This is the spike shape. Okay. And here, because it is the sharp edge, so will because supersonic flow and this is the sharp edge, so we'll get oblique shock here. But we cannot consider that oblique shock formation and all. Why? Because here clearly they have mentioned this is the ideal. This is the ideal. Check. So basically, in general, I will tell you, because this is the sharp edge, so we'll get oblique shock, and in oblique shock, that flow will be slow down, but Mach will be greater than 1, means still supersonic flow will be there, but yes, flow will be slow down in oblique shock. But once normal shock will be formed here, check, once normal shock will be formed here, okay, after multiple oblique shock, normal shock will be formed here, and after normal shock, flow will be 100% subsonic. So this here you can say this flow is now become subsonic. This is the subsonic flow, okay. Here you try to understand, but we are not talking about the shock formation and all, okay. Here as the word, that's the reason I'm explaining, but in ideal ramjet we'll not talk about the shock and all, okay. So but this is the general analysis, okay. First oblique shock will be formed, and because in oblique shock, even after the oblique shock you will have a supersonic flow, hence it is called supersonic compression. But after multiple oblique shock, you may get normal shock, okay. So so after normal shock, flow becomes subsonic, hence it is called subsonic compression, and then process will be continuous, okay. Like in combustion chamber, obviously that flow will be less than 1, means subsonic flow you may have, and again in short CD nozzle it will be accelerated, so again that flow will be greater than 1, means again it will be supersonic, okay. In ramjet, you know very well, a combustion chamber, combustion always occurs subsonic flow, at subsonic flow. But in scramjet, that's the next version of the ramjet. In scramjet, at supersonic combustion uh, process will take place. Okay, but here let me again clear. It should be very clear in your mind. Like this is the ideal ramjet, so we'll not talk about the normal shock and all. Okay, this is not possible. All right, that normal shock and all will not talk about it. Generally, just for the information purpose, I was saying. Anyway, now so check. All right. So see, here we are having a fuel injector. So this fuel will be injected, and this is called a flame holder. This part will be flame holder. So it will be hold the flame, so there should not be any blown out of the flow, okay. And this is what combustion chamber, see this part is a total, it is clearly mentioned, this is the combustion chamber, okay. This is the combustion chamber, so combustion will take place here, and here obviously that flow is what flow down. So definitely it will be called diffuser, or it will be called intake, no, intake or diffuser. This is combustion chamber, this is the expansion, okay. In nozzle, you know, expansion will take place. Expansion means pressure energy will be converting into kinetic energy, and that is the work of the nozzle. So it will try to expand the flow, it will try to accelerate the flow, so that you can get more and more exhaust velocity, and so that you can get more and more thrust, so that aircraft will be propelled in forward direction. That's the whole concept about this. All right. Anyway, now because it is the ideal ramjet, one more thing I want to tell you, in ramjet, see, we don't have any rotatory part. No, we don't have any compressor, we don't have any turbine. Only that's the reason it is called ramjet. What is the mean of ram? So ram effect might be you heard. Ram effect is what? So ram effect means kinetic energy is what converting into pressure energy or pressure rise. Because very high flow is what coming, that intake is what supersonic with very high, obviously high velocity will be there, so means high kinetic energy, and that kinetic energy will be converting into pressure energy, okay. So that process called as a ram effect. All right. So just like a compressor, what is the work of compressor? To raise the pressure, so that whatever the air is what going into combustion chamber, it should be very high pressure, so that combustion can take place easily. But we don't have any compressor and all, so to raise the pressure we'll use the concept, okay, that called ram effect, and in that whatever the kinetic energy we are getting inside the ramjet, that kinetic energy will be more and more kinetic energy will be converting into pressure rise, okay. So that's the reason this whole things like shock formation, and you know, like intake, you will have a supersonic compression and subsonic compression. So in that way you will get pressure rise. All right. Anyway, so uh, in ideal ramjet, what will talk? First of all, we don't have any loss. Second, ideal is also called isentropic flow. What it is called? Isentropic flow. Yes or no? So where is the intake? This is the intake. Check. See, in the intake, we don't have any heat addition, we don't have any heat rejection. In intake, I'm telling. Okay. Similarly, in nozzle also, we don't have any heat addition, we don't have any heat rejection. So means total temperature must be constant in intake. Yes or no? So where is the intake? This is the intake. So total pressure, total temperature, I'm saying. So at point A, what is the total temperature? T naught A. So up to what station we have a intake or diffuser? Up to 2. So at point 2, T naught 2. So T naught A is equal to T naught 2. Why I have equated this? Because first of all, we are not talking about any shock formation. Even though if it is shock also, total temperature must be constant, because we are not adding heat, we are not rejecting heat from the intake. Same thing in nozzle also. What is the nozzle? You check. Nozzle is nothing but at station 4 nozzle started. So here temperature is total temperature T naught 4, and here total temperature T naught 6. So for the nozzle, because we are not adding any heat, we are not rejecting any heat, so T naught 4 is equal to T naught 6. All right. Anyway, similarly, what about combustion chamber? From where combustion chamber started? At station 2, or you can 3, no problem. T naught 2. Okay. T naught 2 and T naught 3. Can we say T naught 2 is equal to T naught 4? No, we cannot say, because T naught 2 does not is equal to T naught 4. Why? Because we are adding heat, so obviously temperature will rise here. So that time total temperature will not be constant. Hope you understood. This is the very basic analysis I am doing here. So if you concentrate, you automatically will learn this Ramjet easily. All right. Number one, this is related to temperature. Why I am doing this? Because I want to draw TS plot also. So for that reason, I am doing this analysis. Okay. So done. What about the total pressure? Because we are saying it is the isentropic. It is the isentropic. Why we are saying? Because it is ideal ramjet. So obviously, or throughout the ramjet, now whatever the flow will have isentropic. So in isentropic flow, that total pressure will be constant. Okay. Why it will be constant? Because we don't have any compressor work, we don't have any turbine work. Total pressure, if we are not having any shock formation, if we are not having any loss, then total pressure must be constant. Another, total pressure is always related to the work. Okay, if any work will be absorbed or work will be transferred or generated, then total pressure will be changed. So we don't have any work check, no compressor, no turbine. So total pressure throughout the engine must be constant. Even we are saying there is no shock formation. If shock formation will be there, then total pressure will not be constant. Why? Because there will be loss. That is the irreversible. What is the shock formation? It is irreversible. So if shock formation will be there, then total pressure will not be constant, let me tell you. But we don't have any shock formation. Why? Because it is clearly mentioned ideal ramjet. Ideal ramjet means isentropic flow. Isentropic flow means obviously there is no shock. Okay. Reversible flow means isentropic flow means adiabatic reversible. That another name. Adiabatic reversible. If reversible flow is there, it means there is no loss. So we can say total pressure must be constant. So what is the pressure at station A? I'm talking about total pressure and total temperature. I'm not talking about static, because whenever you will talk about the engine, you will talk about the total pressure and total temperature. So at station A, what is the total pressure? P naught A. Okay. So obviously we will not have any loss. So P naught is equal to P naught 1 is equal to P naught 2. So we can write here P naught is equal to P naught 1 is equal to P naught 2. Yes or no? And if I'm adding heat in combustion chamber, so definitely total temperature will change. But total pressure, it will not change, because we are not doing any work in combustion chamber. And at the same time, we are not saying any loss in combustion chamber, because losses will be there in combustion chamber for the real engine. Okay. Because we have a turbulence to mix the fuel and air. So because of that, we'll have a loss in combustion for the real engine, I'm saying. But here in combustion chamber, we will say there is no loss. So obviously total pressure will be constant throughout the combustion chamber also. So here at station 3, what is the pressure? P03. At station 4, what is the pressure? P04. So P03 is equal to P04. Why? Because it is the loss-free combustion process. No? So P03 is equal to P04. Hope you all are getting my point. Yes or no? Now, what about phi is generic like nozzle point? What about exit P06? Even if you say P05 also. So P04 is equal to, I will say directly P06. This is for ideal. This is for ideal. Why these all the pressure and all it is same? Only one reason, because it is clearly mentioned it is ideal. Hope now it is very clear to all. It is now very clear to all, I think. Yes? Now, so we'll go for the solution for this problem. All right. Now, so they are asking cruise speed. They are asking cruise speed means aircraft speed, means we need to write VA. We have to calculate this. We'll do that. Anyway, one more remark point you need to write. Basically, this is the derivation. I'm not going to derive anything here. So you need to remember this, okay? All right. So what is the remark point for ideal? For ideal ramjet, what is the Mach number at the inlet is equal to whatever the Mach number at exit. This is very, very important. And this is very simple derivation, but I'm not going to derive here because this is the solution session. Anyway, you make a point for this, okay? Because ideal ramjet 4-5 times they have asked in your exam, so better you remember it. All right. Anyway, like if you want to draw the TS plot for the previous, so you can draw if you want. This is the TS plot for the ideal ramjet. So obviously it will follow the Brayton cycle. Brayton cycle means two constant pressure lines. So this is the two constant pressure line. Okay, two constant pressure line. Flow is what is started or entering at station A first. So first station is A and exit is what at 6. So I will write this is what A and this is what 6. Because it is ideal isentropic, I have to isentropic. No? Entropy must be constant. That's the reason we have a straight line. This is the straight line. And here also we'll have a straight line. Why I'm doing a straight line? I'm drawing here because entropy must be constant. Check, entropy must be constant because it is ideal. So obviously compression will start. Then A2, check up to what station diffuser we have. A2 2. A2 2 is the diffuser. So A2 2 is the diffuser. Once you enter inside the engine, you will have to talk about total quantity. So total. And up to what station we have a combustion chamber? Not 3 or not 4? I think it's a not 3, not 4, sorry. Till not 4 we'll have a combustion chamber. From 2 to 4, check 2 to 4 we have a combustion chamber. So let me correct this. 2 to 4. All right. 2 to and then up to station 6, which is nothing but exit, we'll have a expansion, so drop. Okay. Here, as I told you, if you write the pressure, so I told you like P naught A is equal to P naught 2. This generally I am writing here. P naught 2 is equal to P naught 4. Okay, is equal to P6. Yes or no? or you say P06. Okay, this is very clear to all. It is fully, this is the basically TS plot. Okay, this is the TS plot for the ideal ramjet. No, this is the ideal ramjet. Okay, and obviously whatever the total temperature here, because this is station A and this is the station 2, so total temperature, because it is T naught A is equal to T naught 2. This is the diffuser or intake. So in intake we don't have any heat addition, we don't have any work, so total temperature must be constant. Similarly here, similarly in nozzle also, T naught 4 is equal to, you can write T naught 6. This temperature means at this station and this station total temperature will be constant. All right, this is the TS plot for the RAM rating. Hope is done. So this is the very important point. So I will mark 2 star here. Now we'll solve this problem because they are asking cruise speed. So we'll write this. Okay. What you got here? Check. Anyway. So for ideal ramjet, Mach number MA is equal to ME. What is Mach MA? It is Mach number at inlet. So that is the local velocity of the air. That will be aircraft speed, which is nothing but VA divided by speed of sound, or I will write this local velocity, local speed, which is nothing but local speed of the air, which is nothing but V infinity, and that V infinity is nothing but aircraft speed, VA divided by speed of sound. What is the speed of sound? Gamma R T. Because it is the at inlet condition, so I will write TA. Okay. Similarly, what is the ME? You can write Mach number at exit. Again, local speed. What is the local speed? It is exit velocity divided by speed of sound, which is gamma R T. Because it is exit, so I will write exit. Okay. This is the air, because at exit will have a gas. No? Exit is gas and inlet is what? Air. So gamma of the air we have to write. Okay, and gamma of the exit, which is gas, we have to write. All right. So for the ideal ramjet, this will be equal. This is the simple derivation. Here I'm not going to do derivation, as I told you, because this is the solution session. Okay, GATE solution session, so no derivation. Now we need to calculate VA, cruise speed. We need to calculate cruise speed or aircraft speed, which is nothing but VA. We need to calculate. So we'll take simply ratio, okay, or equate this value. So what we'll get next? What we'll get? VA divided by gamma AR TA is equal to VE gamma ER TE. What is the VA? Check. VA is nothing but VE into, we can write gamma A R TA divided by gamma ER. We'll write all the value here. Check from the problem. Gamma for air, no? Intake. This is the intake and this is the exit. So gamma 1.4, temperature 220, R287, R287 both places. So you can cancel out that. No? And exit gamma is 1.33. What is the exit velocity? 1200 meter per second. We'll write all the data. All right. So 1200 exit velocity. Then we'll write gamma for air 1.4, 287, temperature is 220, I think. No? What is the exit gamma? It is nothing but 1.33. No? 287 into temperature, I forget. What is the temperature? 1100 Kelvin. So we'll calculate this value. How much it is? Wait. First of all, 287 will cancel out. We'll cancel this value. No? So this is nothing but 1200 into, let me complete, 1.4 into 220 divided by 1.33 divided by 1100 to root. So it is nothing but 0.45, 0.458 better into, we'll write 1200. So I'm getting 550.59 meter per. This is the cruise speed, no? This is the answer. Yes or no? Take this is the fill in the blank, I think. Ramjet. So what is the speed? You need to write rounded up to nearest integer. You better you write 550.5 now. So nearest integer you can write 550 or 551. That data any. This is your answer. 550. You can write. All right. So I hope this was the brief description about ideal ramjet, first ramjet, and then ideal ramjet concept I told you. What are the assumptions for ideal ramjet? Here all the value I have written. So you need to remember, this is very important things related to ramjet. Here it is written. This is ideal ramjet assumption. Okay, should be very clear to all. And a very important ideal ramjet, this is the outcome of the ideal ramjet. Once you apply all the assumptions, you may get this result: ma is equal to me. Simply you equate and write the Mach number formula: local speed divided by speed of sound. Speed of sound you know very well, root of gamma RT. You just do that further calculation. Finally you will get 550.59. So integer they are saying, okay, write 550. That is enough. All right. So I hope you all understand this. So you guys like and subscribe the channel. So whatever, like when I will upload the videos, so directly you will get notification for the new video and all. So like and subscribe the channel and keep doing hard work. Okay. So thank you all. Thank you so much.